I'm good. Unique. Starting with else to ask me. Yeah, I was muting myself when I was talking. And guys, I hope I'm audible now. So can you please confirm? And yeah, hi Manish. Hey man, how are you? Yeah, it is audible. Great. Let me tell what we are going to see now. Uh, I think today it will be a long one, so that's why I pre-plotted from 6:30 to 6 today because I wanted to complete both feature engineering, encoding categorical features, which is the second step of feature engineering, as well as outlier handling together in this one session itself. Okay, so that's why I have made it as a long session today, pre-plotting it to 6 p.m. Okay, so yeah, I think there is no doubts, I guess. They have one. Yeah, headphones. Okay, let me start the session. Okay, so let me share my screen. So if you got any doubts, just say okay. So what we are going to see today, we are going to see how to handle categorical features, and along with that, outlier and its handling. Okay, this is the topic we are going to see in today's session. So okay, so these are the two topics we are going to see today. So let me start the today's session. After that, if you have any doubts from today's session, just put them in the chat. Okay. So yeah, let's go for handling categorical feature. Okay. So this step we usually call it as encoding categorical feature. Okay. So why this process is needed? Okay. What is this encoding process all about? Okay. These are the two questions we are need to see main at the first, and then we'll see types to do this process. This step, however you want to call it, types to do this step. We are going to see about these three things in detail. Okay. So first, we'll answer the question why. Because categorical feature are in the form of string, right? So if you do in detail, actually it will be object. Okay. But our model can't learn this. Model can't interpret object. Okay. So our model can learn only from numbers. So somehow, I don't know how, yeah, somehow we need to convert this object into int. Okay. Object is like with a string and with alphanumerical characters, everything like that. We get it as object data type. I think you all know what is object data type by now. Okay. Are we going to use the previous dataset in which missing values were handled? Yeah, the dataset will be same, obviously, but yeah, I'll run this folder whatever I've run. at the last time again, and then I'll be doing encoding categorical features also in that file itself. Okay, so that's why I have not uploaded that feature engineering file yet. So, yeah. So now our aim, our aim is to somehow convert this object into int. Okay, so some examples of object is, for example, here there is transaction here. Okay, so we are having money share in the line, and then yeah, and there, so wasn't okay. These are all objects. If somehow I can convert these into numbers, for example, 0, 1, and 2, this process is called encoding. Okay, so that's answer the question what. Okay, encoding is a process which will converting object into categories into int. Okay, so this is what is a brief thing about why we are doing categorical feature handling, why we are encoding it, and then what is categorical feature encoding. That's what is the answer for these two questions. Now, types to step. So again, like as I said yesterday, these are not the only types which is available. You can do whatever type you want. Okay, one hot encoder, label encoder, target, guided, ordinal encoding. Okay, so is there any doubts? Okay, there is no doubts there. Okay, target guided ordinal encoding, target guided bean encoding, and then we are also having a thing called count encoding. Okay, these are all the things which is available. So other than this, there is some other types also, but these are all commonly used. Okay, so in this specifically, I first prefer ordinal encoding, this one, and then this one. So this is not under this, if it is a binary column, I straight away do one hot encoder. Okay, if it is having more categories, first one will be target data ordinal, and then label encoder. So third option will be this. My least favorite is count encoding. Okay, so yeah, these are all for more than two categories in a column. Okay, so as like the previous class first, I explain what we will be doing in all these methods, and then I'll say what is the hands-on for it. Okay, so let us go for one hot encoder first. One hot encoder. Okay, what is this process? How else we should when we say it as process, one hot encoding. Okay, so for example, I'm having three categories. Okay, yes, Chennai, and then cutie coding, and then Thornbury. Okay, these are from three cities in Tamil Nadu. So if you don't know, just assume it as places. Okay, so yeah, these are all three places. If somehow I can convert these into a number. How will I able to do? For example, I'm having a data. Okay, so yeah, if the row is having a Chennai, okay, what I will do is I'll have one in Chennai. Okay, these are all the column which is representing that ch underscore one, something like that. You can remember qt underscore one and qt underscore one for representing these. Okay, in ch alone I'll be having one, and in qt and third I'll have zero. So for qt it will be like 0, 1 and 0. For 3 also it will be 0, 0, 1. So at this time, what we will do is we'll be dropping this column, okay, on a separate column. So this is how it will get encoded. Okay, we'll be dropping this column to reduce the dimensionality. Okay, to reduce this dimensionality, we'll be dropping this first column. So here you can assume, like, the problem is why we are just using it for binary is that it will be increasing the column once the category increases. Column increases with increasing categories. Okay, so they are both are directly proportional. So that's why we usually prefer it for binary, because see here, for example, the most common binary column is gender. Okay, that is the most common binary column. So gender is usually we are given it as male and female. Okay, what I'll encode here, 0 and 1 and 1 and 0. So what we can do here is we can drop this first column. Okay, so if I drop that column, what will happen is 1 and then 0. That will be our thing, like, one for male and then another one for female. So we can know is indirectly, if male is 0, we'll know that female is 1, and if female is 1, the male is 0. That's all, simple. Okay, so this is what about one hot encoding. So I hope you got it. This is one of the simplest encoding. Okay, but yeah, very useful in encoding binary columns. Okay, binary categorical columns. So next we are having label encoder. So for label encoder, for example, I'm having some 10 cities, rainfall cities. Okay, I don't know which is the good city or bad city. I'm just going to write it as A, B, C, D, and E. Okay, so consider that here the rainfall is good in B first, D second, C third, A4, and E5. So here the label encoder, what it will do is it is trying to create this kind of a rank. Okay, it is creating a rank among this categories, and it is encoding this rank to this category. So what will happen is now A will be encoded as 4, B will be encoded as 1, C will be encoded as 3, D will be encoded as 2, and then E5. Okay, so simple. Like, whenever you are able to find that there will be kind of a rank. Actually, this is one of the most commonly used encoder. Actually, whenever you are having more than two columns, this is the most commonly used encoder because this performs very well. Okay, so yeah, at the time you can use label encoder. All right. So next we are having target guided ordinal encoding. So I'm just going to say the theoretical part. Okay. So how it works usually. I'll be saying that, but I'm not going to say it line by line. Okay, so here it was very simple, but here it is upon you. Target me with ordinal encoding just means that somehow you need to give. The principle is you need to encode with the whole number. That's why it is ordinal encoding. Okay, whole number like 0, 1. Okay, by some correlation or else some relation with the dependent column or else dependent feature. I hope you all know what is dependent feature, which is the output feature. That's why I always prefer this method because this will increase our correlation. Accuracy. Correlation with the column. Okay, so usually label encoder will create a rank by itself without even considering the target column. But we are doing the same thing almost, but we are considering the target column. There are different ways to do that. One of our famous method I'll show you when we are doing it in hands-on. Okay. So next we are having target guided need encoding. Okay. So what is this target guided need encoding? Same thing, like even there it was a ordinal number, and here mean is given because we use mean there, but I don't want to say now itself what kind of a mean I'm going to talk about. We'll be using some kind of a mean value which will be in decimals. Yeah, so 9 point or else 8 point, whatever it is, it will be there. And there also we can do simple. Most of the steps will be same for target guided ordinal encoding and target guided mean encoding. Just only one final step will differ. I'll show what it is. Okay. And then finally we are having something called count encoding. Okay. This is the simplest method. For example, in a column, maybe this is a column and I'm having A, B, C. Okay. If I want to encode it as A, I'll just do it as 2. For B1 and then C1, this will become a problem, right? Because both of them will have same value, so it will not understand difference between B and C. That's why this is least preferred. Okay, so just know the advantages also and disadvantages also. So considering the advantages and disadvantages, okay, so one hot encoding has this problem of loss of dimensionality. Label encoder performs very well only if it is able to get a rank. Okay, it may become an advantage or disadvantage based on your data set. And then target guided ordinal encoding, it is a feature you have written by you. It's upon you how you're defining that target guiding. Okay, that target guiding process you are doing by your own. So it depends on you. Okay, same goes for me. And then count encoding. Uh, yeah, that has a lot of problems. So that's why no one use this encoding, count encoding. So these are some types. So even for date, we can do ordinal encoding. How is that? I'll say the process alone because we're not having that kind of feature in our column, but I'll say the process. Okay. For date also, we can do thing called ordinal encoding. Usually, we don't do like this. We used to handle date feature in a different way. So if you want to encode the date, what you can do is first convert the date into a day of a week. For example, today it is 0609, right? Convert it into Monday. So always you'll be having Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, right? So just do either of label encoder on that or else target guided ordinal encoder. So that's how you can handle date feature also. That feature also can be handled in the same way. So that's why I didn't put it in a separate way because we are just using either of these after adding an extra step there. Okay, but yeah, we are not in need to do that for this specific project at least. Okay, so yeah, let me take your questions. Is there any questions till now? Let me give you some 1 or 2 minutes, and then yeah, we can go on with the hands-on. So after that, I'll be doing outlier handling, and then yeah, today will be completed. So possibly if needed, I'll also take feature scaling. Okay, if you have time. Can you help with the use case where date should be encoded with day of week? Yeah, sure. I said you right. Let me first convert it into day. Like I'm just sharing it. Okay. So it is not in our project, whatever we are doing it in bootcamp. But yeah, you can follow this way. Okay. So that's why I said you right in my repository, everything is available. So let's see where it is handling categorical feature. Uh, so here, if you see here, first I'm getting some date here. Okay, I'm just taking it here. Okay, and I'm getting the day. Okay, I'm creating a column called day, and then for this day, I'm taking the corresponding day, and then yeah, usually just encode it, and yeah, you are done with encoding, right? It has been just encoded. But see the problem, like it will be always same. The date will lose its importance, right? Like for example, if it is just weekend or weekday, right, then it will be easy for you. Like encode it as, for example, sales of a market, whatever it is. Like for example, sales of a supermarket. Usually, the sales will be very good on Saturday and Sunday. That's fine. But what about the 5 days? We can't say anything, right? So that's why, yeah, this is a method you can encode. But yeah, I would suggest to just split it, like just split it as day, month, and year. That's how I have handled it in our column, like our project. See here, just a minute, I'll show you. I said you earlier, this project will have everything, like everything, whatever we think of will be there in this project. Which is very efficient. Is it handled or not? Yeah, I've handled it. So some place at the top. Also including, so somewhere here I'm doing this. See here. Huh. I'm getting the date. Actually, it is not in a date format. It is in a format of string. So I'm converting into date, and then I'm getting the month and day. I'm not giving importance to year because year doesn't play important role in this specifically. So I didn't give year. I just gave month and day. Okay. So that alone is now created specifically. Okay. But yeah, if you need it, you can also give years. So this is how I will suggest to encode the date instead of using that kind of an encoding. Yeah, it depends on the problem. But see, like why? How you can think like it depends on the problem? Like see, uh, always you will not have a simple problem where you can just encode it in a weekday. So can you think of any use case? Just like just for weekday or weekend. If it is like that, yeah, you can like do like this. Because every day Monday can be an important feature, and some weeks Tuesday can be an important feature. feature, right? So that's why I'm not suggesting, but yeah, we can accept that it depends on the problem. So I have one question. Yeah, please put forward your question. Taking the date as the day of the week. See, that's what I'm saying, right? Like, see, for example, uh, is like, one having the same importance as eight. As you said, supermarket holds good. For example, I'm putting the same way to you. Usually, a supermarket will run good at the beginning of the month and the end of the month. Okay. So what about the middle of the month? So if like, do you think the importance of the supermarket will be same as the beginning of the month and the middle of the month? I don't think so, because a lot of guys prefer buying all the stocks of the home at the beginning of the month itself. So that's why I said, right, like, I don't prefer that kind of a way. Like, first Monday, is it going to be that equal in the second Monday? No, I don't think so. That's why I said, right, like, don't encode this kind of a way. Just prefer what I said now, right? Like, when you're doing this project, you'll be getting to know, like, that is the best way to encode it. Did you get it? And if you can say okay, then we'll move into the hands-on. And if you're not okay, just put your question. I'll answer that, and then let's move on with the hands-on. Okay. Okay. Then I'll take that as a yes that you understood. Now then, let's go on with the hands-on. Okay. So yeah, here it is. So let me run this. Then the data. Just going to run all the columns. Only query this is just for the learning purpose, right? So whatever you get doesn't matter. So if you get any other, just try to resolve it. Okay? Other than that, if you get any error, just cancel it. So yeah, until then, guys, like, if you have any doubts, please ask it. Like, we have completed about the different ways to import the features. So yeah, just post your questions related to that. I'll take a minute or else to know that, and then we'll move on to answer of that. Okay, because next we are having outline handling. Okay, so I think here also it will be run, and I don't think you guys have a doubt. Okay, now for handling categorical features. Okay, now somehow I find a binary column, but I don't think there is a binary column here. Yeah, here it is. Rain tomorrow and rain today. It is there. Okay, so first let's start with let's go with encoding. Encoding. No, we are not going to do like this. Okay, df of feature Okay? Don't forget to put drop underscore first equal to true. Okay, simple. This much. Okay, so one hot encoding is, as I said, the simplest way. Okay, so just run this and let's do one hot encoding now. If command not being does good, let's move for rain model. Okay, our output column. Let's see here for df dot dfs. Here there are all objects. So previously even our rain tomorrow was an object. Now it has become u int 8. Yeah, you can also convert it into other types. It's upon you. Okay, I guess. Yeah. So basically it's now u int 8, and if you need, you can convert it into any other targets. Have you ever come across two or more targets? What do you mean by two or more targets? Two or more categories in target variable models, two or more columns. What do you mean by two or more targets? What is HLD, LLD, how to maintain it while coding? Okay, so I think you are doing ideal internship, I guess. Ajit, am I right? What is HLD, LLD, how to maintain it while coding? So target columns. Okay. So actually at that time try to consider it as kind of a multi-level classification. So yeah, I'll do it. Okay. So don't worry, Lakshmi, I'll make a video on it soon. Uh, I'll make a video on it soon. Thanks for just saying me that I didn't think of that perspective. Okay. So in this column, this is the beginner's bootcamp, so I didn't think of to take two or three target columns. But yeah, I'll soon make a video on how to handle two or three target columns. Okay. And Aditya, we are saying yes, you are right. Don't worry. So I'll be surely making a final doubt session, kind of ask me anything kind of a session at the end of this bootcamp. At the time, I'll be clearing about what is HLD, LLD, and I'll clear everything what I have on HLD, LLD. Okay. And that session will be a generalized session. Even now, I'm giving generalized things, but like when I'm discussing about HLD and LLD, it will take time because it is a long concept to discuss about. Okay. But that session will be nice. You can ask anything you want on data science. Okay. So yeah, now we have seen about one part encoding, right? Next we are having label encoder. So for that, you need to first install Cyclic. Okay. So just install it. Just waiting for this. Yeah, now it's fine. Just do quick CMD instant Cyclic hyphen. I think you all know what is Cyclic. Okay. So just install it. Okay. It will take maybe some time. Not long. Okay, now it's good. So I'm adding this also. So let's import it. Okay. I don't think there will be a lot of coding. Okay, don't do this at all. Okay. Let's do Circuit. Sorry, not circuit. External dot precursor import label encoder. Okay. LE just have it as whatever you want. I prefer to have it as itself. As it is very self-explanatory, it will be very easy for me to remember it. But you want, if you want, just have it as encodable. So yeah, that's it actually. This is also very simple actually. Okay, let's run this and let's see if it will work. Okay, which column should I take? Um, Maybe Day4 Winduster should be fine. Any object column should work well. Location, I'm having a special thing to talk about that. Let's go with Winduster itself. Okay. Um, label, label encoding, encoder, you will run into any errors. It didn't run. See here. You have got three types. First, let's see the type. Okay. And then I'll also print the DF column. See now, Windows Player has become Win64. Okay. So let me print the DF also. Where is it? See here, 13, 14, 15, 4. It's printed, right? Okay. So this is what you do label input. There is a continuous noise in audio make it little zoom on screen when you can while coding or you can maximize code base code size window. Okay. Just give me a minute. These are all needed. Also increase the size. Just give me a minute. And I hope now this thing won't be there, right? The sound, like the noise. Yeah, I think it won't be there. What's the font size? So just yes, 24. Okay. I think now it should be more visible because it's very huge actually to my eyes, right? So it's very huge. Okay. So yeah, that's about level encoding. Let's go for target, guided, ordinal encoding. This. Okay, this is just showing like a new feature which I was talking about yesterday, right? Like when I was speaking about missing values, I was saying this actually to you. So that's what it is showing now. But we don't need that actually. What we need is we need actually two columns here. Okay, we don't need just the normal feature. We also need the dependent feature. Okay, audio distortion is still there. So is my audio breaking or else there is noise? Which is there actually? Please confirm it once. How is it now? Maybe. Just a noise. How is it now? Yeah, yeah. Actually, it's from my side only, I guess, because everyone is addressing it. How is it now? Your voice is still audible. No, no, no. Obviously, it need to be clear for you, all right? So just say like if it is clear or not now. Is it clear? Yeah, it's good now. So actually, I've turned on my fan. So let me keep my video off only. Okay. So yeah, I'll just do one. Okay. So let me go on with this. We don't need this much. Why it's printing like this? Okay. Now we need to get feature features label. Okay. For that, what we will do is we are going to do an interesting method which is called df dot group by, okay, which will be feature and dependent feature. I'll just take it this also as like this. Okay. And I'll be sorting these values. Dot sort underscore values. Ascending is equal to false because I need to give more importance to the descending values, like the top one, and then I'm getting the index of it. So let me print this separately for one feature. Okay, df dot group by of, for example, when dir 9am is in column, I guess. When dir 9 a.m. in tomorrow, and we are getting the mean of it. Okay, so here if you see, this is how it is coming. Okay, and in w this is more important, and n, and then because this is the most one present actually. Okay, but yeah, you can also do some different things. Okay, so I'll show you one of the interesting one. Actually, no one used to do this like this, but I just preferred it. Okay, so see guys, like this is about a domain knowledge. We need to prefer rainfall. Okay, we need to have rainfall because our data is biased towards not rainfall, so I'm just giving more importance to rainfall. So what I done is I just created a new column where I was taking this. Okay, I'm just copy pasting this here. I'll explain this. Okay, if I'm doing like this itself alone, what it will do is it will just give me. Okay, it will say like rain one. That's all, simple. But if I'm doing this thing, unstack along with that, extremely beautiful. See, for example, in Adelaide, there are 2505 Adelaides. Like in 2505 rows, there is Adelaides which is having zero rainfall. Like there is not rain, and then in 688 rows, there is Adelaide where there has been rainfall. So similarly, for all the things you get it. Okay. So what you can do is just you can create a new data frame out of this, and then take the this column, one column. Okay, I'm just doing that only. See here. So df of, one. Okay, just a minute. So we are just printing this first one. Okay, so I'm just maybe going to have it as a separate df. Okay, this is also target guided online encoding, and that which I shown previously is also a target guided online encoding. There are different ways, as I said, but the one thing is this proven to be the better option. Okay, then I preferred rainfall for tomorrow, right? Then gave me a good encoding actually, and yeah, you can do it for all of those actually. Okay, not encoding it. I just print BF1 once. Okay, should have been like this only. I don't know why it's printing like this. This is what even I have taken there. Okay, maybe. Okay, yeah. This is my problem. Now it's working. See here. Now Portland is the city where there is lot of rainfall. Okay, there is 1095 rows which is having rainfall actually. Okay, so that's why I'm preferring that. So what you can do is just put an enumerate function. Okay, just an enumerate function over this data frame and try to encode it. Simple. For this 0, 1, 2, 3, 4, that's all. Okay, it will be awesome. So also you can do manually also. If you want to prefer one thing over another, you can just do this. I'm not doing an enumerate. Okay, because in one thing alone I changed it. So what you can do is just map this. I think you all know what is a map function. Okay, df of yes, location dot equal to dot map actually. Yeah, here it is. So now if I print df, see here, it's encoded. Okay, so here also you can see that similar encoding. Okay, that's why I didn't do any enumerate to just show you. Okay, but yeah, you can also do an enumerate function. Unstack is interesting. Actually, it is one of the best methods you can get in pandas because if you see, like unstack is just to like remove this things. Like for example, you're having three categories and you want to see which is overpowering those. Just use an unstack. That's all. It will be awesome. Unstack is actually a good way to do this target guide and ordinary encoding. Okay. So yeah, for that I didn't think I completed the function. So let me complete that function. Okay. Okay. So this I think you got it right. So I'm just making a group by, and then I'm making a mean of it, mean like which is having the most one, and then I'm sorting it. Okay. So by this I'm getting the most occurring label. So for that I'm just making an enumerate function. Feature label 2 equal to just a dict k comma. Okay, I don't need this. I is to I or I comma k in enumerate of feature label. Okay, so this is what we needed. So now just do df of feature equal to df of feature dot map of label 2. That's all. Okay, this is what target guided ordinal encoding is. Okay, so what you can do is just take a function. Okay, target guided encoding df of rain today with respect to rain tomorrow. No, we don't need that. Rain today is just handled by getW. So let's do wind there 3 p.m. Okay. Now let's do the df.dtypes. See here, actually we are having only now this object. This has object rain today. Okay, rain today can be done by that thing which I said you, like um, one hot encoding. Window 9 a.m. can be done by using this target guided date. As I said you, we need to split it. Okay, so yeah, that's about encoding. Okay, so for mean encoding we are not going to do anything. Okay, simple thing is I'm just showing you the difference alone. I'm not going to write it actually. So here I'm doing this mean, right? I'll be just taking this mean itself. I'll not be doing any enumerate. I'll be just taking that mean itself. What I'll be doing is this mean, I'll just put it as, where it is mine. Okay, I'll just copy paste it so that I'll be able to explain it. Okay, core mean, simple. Just a minute. Uh, yeah, here it is. 2, 8. That's all. I'll be mapping the feature level 1 itself. That's all. Okay. There is no label 1. Why am I doing target? I'll just take it as green and there. Polygon. So that we won't be confused. I'm not going to do it ppm. I'm just going to take line here. Now let's print df now. Okay. Let's see the difference. df.t types first. Where is 9 a.m.? See, that is also now 464. If I print df, maybe first I'll show you the df before that. Okay. Where is this? See, 9 a.m. and then nw. Okay. It will become different. See here, it is in some decimals, right? Some percentage. This is a percentage. That's all. Okay. So yeah, that's about handling categorical features. Okay, these are some different methods which I've shown you now, and let's now move on to outlier handling. So outlier detection and outlier handling also should be there. So yeah, until then, I'll first take your questions, guys. Is it clear? Like the hands-on, the codes. Is it clear? Is it clear? Just put it in the chat. We're waiting for it. Yes, please. Okay. Okay. That's great. So is my voice clear? Can you please confirm that also? For that, just turn on the fan. Keep it in different. Okay. So yeah, first I think you all know boxplot, right? We'll be using that. Okay. So for boxplot, I'm not just going to talk about that. I'm not explaining that. Take the boxplot. Okay. Okay. Need to first take it as something. Okay, these are all some old codes, so I think for it. Okay. So now what we are going to do is first we are going to detect it by using so to do the socket. And for outliers, I think one of what I did now. Let's now see about where we need to be handled, how it is done. Okay, same questions. Outlier. Okay, outliers kind of a rare occurrence. Speak of it. I used to think like this. We say like what it is because we can't say it in C. It says in say it as an explanation for it's a graph and where I'm plotting some. rainfall, okay, with respect to year. So it has been following some pattern. Okay. But all of a sudden, in 1 year, what happened? One to next year also, it's the same pattern for following some pattern. So this is very, it is a very irrelevant date. So this we call it as. Okay. So this kind of an outlet, it will do this. It will disturb our model. Okay, for example, there is linear regression, or actually I should not explain, but sorry, y is equal to c. But if I take 6, what happens in linear regression? Make a line for fitting all of it. What will happen is it should be trying to fill like that. Okay, but due to this one, it's large happen to our line from here to here. It will not even connect anything. Okay. So by this error is getting increased. You are not getting the best feedback. Okay. So you can ask like often it's every ML algorithm affected by outlier, not every algorithm. Wherever there is distant distance, be it Euclidean distance, then whatever distance you are trying, Euclidean distance is telling k-means, k and all will be Euclidean. So at there and all, it's like kind of prone to trends. So which algorithm should be based? Be based on, yeah, it will be almost simple because it is just taking branches. It's not taking distance to make a bit. The problem of outlier. Yeah. So that's why everyone prefer 60 boost. So even I prefer can boost model and SVM as my second. Okay. Yeah, that's my favorite. Nothing to say about that. Yeah. So yeah, little breaking and losing some these related to PS. Yeah. So I think it should be now clear. I think now it should be clear. For tomorrow, don't worry guys. I'll do something for this noise issue. Okay. Till today it was not there. But all of a sudden, if it is coming today, I need to rectify it, and I'll rectify it. Okay. So your half of the words are not coming to us. Is it also now? Is that problem coming now also? Yeah, it's clear now. Okay, then not an issue, not an issue. Okay, so for outliers, as I said, okay, tree-based algorithms are not prone to outliers, but any algorithm which is based on gradient descent or else Euclidean distance, anything where there is a distance computation, it is prone to outliers. Okay, so for this also I have mentioned actually already. Not in this. Let me go to outlier handling to show you which are all the algorithms prone. Okay. Mhm. See here, naive bias is not sensitive. Not sensitive means not prone. Okay. SVM, no. Linear regression, yes. Logistic, yes. Decision tree, no. Any ensemble models like RF means random forest, XGBoost, like GBM, gradient boosting, or else like can boost anything is not prone. Okay, KNN actually it's prone. I've missed it. Okay, it is prone. K means it's prone. Hierarchical it's prone. PCI is prone. Neural network it is the most prone. Very very sensitive. Okay, neural network it's very very sensitive. So whenever you are having neural network included, you should must do this outlier handling. Okay, so yeah, it's clear not now. So yeah, now the problem is not there, right? So that's what you're trying to say, right? The audio issue is not there, right? Okay, I'll take that as a yes, that I don't have any audio issues. Okay, so let us see what are the ways to detect it. Okay, so we can go for a statistical way where we can use IQR or else Z score, okay, or else graphical way where we can use box plot or else scatter plot. Of all these methods to detect, I use box plot. For handling, I use IQR. Okay, IQR means inter quartile quantile, interquartile range. Okay, so I prefer interquartile range. So what is that interquartile range? Is that IQR is equal to third quantile minus first quantile. Okay, so this is called interquartile range. So we prefer our data to be in this range. Okay, so what we will do is we'll create kind of a bridge. Okay, so this will be our IQR. Okay, so what we'll do is we'll be accepting more than this and this, so not more than this will be allowed. Okay, this kind of an IQR we'll be doing. For calculating the lower bridge, what we'll do is first quantile of the data minus IQR into 1.25. This 1.25 is kind of a parameter which you can play with. Okay, it's not always 1.25 or else 1.5. Whatever you want, you can just do it. Like actually, common things are 1.5 and 3. At times also you might need 2 or 3. 3 is like to remove extreme way. Like you will not even have a single outlier. 1.5 is to remove some amount of outlier, so that's why I always prefer 1.5 over 3. So what you can do is just use this 1.5. Okay, it will just allow first quantile with some amount of values multiplied by 1.5 before that. Okay, other than that, it won't allow any values. Okay, so similarly, I'll be doing plus for the third quantile. So I'll be making this kind of a cushion, and this will be a quantile range. Okay, so that's how we'll be handling the outlier by using IQR. Okay, so yeah, so I think you all know what is a quantile. So percentile and quantile, I need to make a topic on that also now, because or else you will not be able to understand what is quantile here. Sorry, I'm just going to stats also, because if I don't talk, you won't be able to understand. So consider that you are having um, 20, 30, 40, 70, 80, 90, and 100. So what is this 50 here? It is 50 percentile. Okay, it is the 50 percentile of the 100. Okay, so here actually there should be this one which is 25 percentile. Actually, there should be a 25, which will be 25 percentile. Okay, so we used to use this percentile in JE mark. So whoever who says JE marks, they'll say like percentile. I've scored 20 percentile, which means of the first mark score, he has scored 20% out of that. Okay. So here, what is quantile is that we'll be splitting it as 25, 50, 75, and 100. So this is the first quantile, second, third, and then fourth. Okay, so here I'll be taking this as my range, and every data I prefer it to be in this range. So this is the IQR, and I'll be creating some cushion before and after that. Okay, so yeah, I hope you got the point about outliers. So guys, can you please confirm about outlier handling if you got the point, so that we can move into the hands-on where I'll show how to do this box plot and then handle it using IQR. Please put it in the chat, guys. Got it. Awesome. Awesome, awesome, man. Awesome. Great. So see, now coming to the way of detection. Okay. See here. So location actually it's encoded, so it is not having. Okay. But usually we do outlier handling, uh, like for continuous features alone. But what we have done is after that. Okay. So we should have run this continuous feature before that. So yeah, don't worry. It's for learning purpose, right? So we need not worry on that at all. So these are all outliers. This is the center, okay, and this is before and after. Okay, this is the mean actually, the center line. So these are all outliers. Okay, we need to handle it. How we are going to handle it? I'll just show you. Okay, so we are having a lot of columns which are having a lot of problems. Okay, so yeah, let us go on with IQ. F I Q R. Awesome. Literally, it's awesome. IQR is equal to DF of feature of quartile, which should be actually minusing this actually. Okay, minus, why it is like that? Okay, see here, it's actually doing this IQR job itself, but we don't need it. Okay, so what we'll be needing is, uh, yeah, I think it's a separate step actually. Yeah, just calculating the IQR. Okay, now we'll be doing lower underscore bridge equal to Q1 minus 1.5 star IQR. Great. That's what it is. Okay. Upper bridge is equal to that. And yeah, we'll be just taking this lower bridge and upper bridge if we just want to detect it. But we are not just going to detect it, right? We are going to handle it. So what we'll do is df dot location, okay, df dot lock, df of feature lower than or equal to lower bridge. I mean, lower than or equal to means less than or equal to lower bridge because I don't want anything to be lesser than that. Okay, comma feature will be equal to lower bridge. Okay, I'm just saying the values. Like if it is lesser than lower bridge for that feature, just give it as lower bridge. That's all. Can you please explain about lower bridge again? So yeah, you itself said got it. Thank you. Okay. So similarly for upper bridge, greater than or equal to. That's all. Okay. So now let me run this. Okay. do IQ or okay. I'll just do IQ off. Day4 maybe min temp. Okay, I think it was having outliers. Let's check once. Which is having outliers. Okay, max temp, random, max temp, mean. These and all are not needed. I'll just go for a column which will be good. Temp 9 a.m. Yeah, temp 9 a.m. should be a good column. Okay. So let me go for temp 9 a.m. And guys, I'm not restricting you to any columns. You just test with any columns. Okay. Just see how much it is going. That's all. 9 a.m. Now let's do SNS dot box plot of df of temp 9 a.m. See here. No outliers now. Okay. See, previously there were outliers. Okay. Outliers are there. Now, no outliers. Zero. Everything is removed and then put here. Okay. In this outsides. So that's the good thing about IQR. Okay. That's the best way I prefer to do outlier handling. So yeah. So what do you think, guys? Like, what is your doubts here? Like, are you having any doubts now? And just say, like, I was just planning for handling categorical features and outlier handling. Shall I move on to the next step of feature scaling, or else shall I do it in the next session, which is tomorrow? Because it's 1 hour 20 minutes now. If you are able to, like, listen more, I will also take feature scaling. I don't have an issue. Just it's upon you. Yeah. Just say, guys, like, do you want or like, it's upon you. And not the middle value. So we are equally distributing as lower which and upper which not. No, no, we are not equally distributing it. See, we are taking, like, for example, my lower bridge value is 10, okay, and I'm having some value called minus 10. So what I'll do is I'll be changing that minus 10 to 10. That's all. If it is lesser than 10, I'll be just putting it as 10. If it is greater than maybe our upper which is 50, I'll just put it as 50. Okay. So we are not equally distributing as lower bridge and upper bridge. That is not our aim. Like, we are just making sure that that is the end range for our data set. Okay. Sorry, calculating and scaling. No, what is calculating and scaling? What do you mean by that? I'm not communicated. Can you please rephrase your question, Dhanlakshmi? You were saying, sorry, calculating, scaling. What do you mean by that? And until then, if you have any other doubts, just ask that also. So calculating the way it's scaled. Okay, like, I'm just creating a question. That's all. Like, it's not a middle value. I'm just taking 1.5 times the IQR before that, before the lower bridge, as the lower bridge. Okay, the way it is scaled. It's not scaled actually. The scaling is done when we are uh, removing the outliers. Like, we are scaling it to this range of upper bridge and lower bridge. So at the time, if you are mentioning about scaling, yes, we are scaling it, and it's between lower bridge and upper bridge. Then you are right. Sorry if it's confusing, but you have answered it already. Okay, hi, yeah. Actually, it's kind of a confusing question only. There is another confusing question, a beautiful question, usually asked in interviews. There is a question called precision and recall. It's a good topic, usually asked in interviews. So I'll also talk about that when we are talking about performance metrics. I'll be talking about that. Okay. So yeah, I just say like shall we wind up or else shall I continue? You just say like, shall I wind up or continue? If I need to continue, I need to go for feature scaling, which is a new concept, or else I can just wind up. Okay. So why thank you? Are you meaning by just like wind up the session? Are you meaning by that? I'll just turn off my screen share also, please. Um, we may have it tomorrow. Okay, sure. What will be your next step? Ajit Yadav, we have our next step is to do feature scaling, and another thing is to do train test split. And if needed, feature extraction. I'll not. I'll just say what is feature extraction and what is the thing, why we are doing it. As usual, like what, why, how. That's what I'll say. But I'm not going to do hands-on because we don't need feature extraction yet. But yeah, at times you might need feature extraction. I'll be saying about that also. So once these are done, just do train test split, and we are ready to do model. So we are very close to do our models actually. Models is just 10 minutes or 15 minutes of work. That's all. And once model is done, I'll tune it and then we'll move into deployment. Simple. Okay, thanks. Okay, that's great. I hope you don't have any queries. So if you don't have any queries, let's wind up the session now. Hope the code will be uploaded. Yes, once outlier handling also is done, I'll format this code such that it will be run one below the other. Okay, and yeah, I'll send you. I'll upload the code. Until then, just wait, because this is for complete feature engineering. I'm just keeping this notebook, and once it is done, I'll be just converting it to a CSV file, and then I'll just upload this notebook there. Okay. Okay. Yeah. Then I think let's wind up the session. So thank you for joining. Okay. So if you have not subscribed the channel, please do subscribe it. Okay. I'm taking a lot of efforts to do community session. Okay. It's not about getting subscriber, it's about reaching more people. And then if you like the video, just like it and then write the comment section. Okay. So yeah, thank you all. I'll see you all in the next session. So until then, yeah, happy learning. Okay. Bye.